All right, number 1. The error in factoring was when they took out from the second set of numbers, they only took out a positive 9, whereas we really should have taken out a negative 9. So this should have been x squared out of the first set, negative 9 out of the second set, so when I have the factored form, x squared minus 9 actually factors further. It's a difference of two perfect squares, the first one being x, the second one being 3. So my final form would be x plus 6, x plus 3, x minus 3. All right, you can complete number 2 on your own. Same with 3 and 4. Number 5, looking at the table of values, what are the factors of this polynomial? So the first thing we would do is identify the zeros. So 1, 0, anything where f of x is 0 is negative 2, which makes a factor x plus 2. We have another 0 here when x is 1, so that would be x minus 1. And we have another one here at 3, making it x minus 3. To divide using synthetic division, we take the factor, set it equal to 0, so we know the 0 value. That goes on the outside of our L. We put the coefficients across the top. If there was any missing, we would put a 0 in its place. We bring down the first term. We multiply outside times bottom, put the result in the next column, and now add. 1 plus negative 2 is negative 1. Multiply again, we get positive 2, which becomes negative 30. Multiply again, we get positive 60, which gives me a remainder of 0. So first of all, this tells me that x plus 2 was a factor, and x equals negative 2 was a 0 or a solution. And the answer, starting 1 degree lower, is 1x squared minus 1x minus 30. There's no remainder, so there's nothing else I would write there. If I looked at number 7, if it's x minus 2, that means I'm going to be using a positive 2 on the outside of my L. So we have 1, 11, 31, and 21. Bring the first number down. Multiply and add. Multiply and add. Multiply and add. So our result here is a remainder. So that means x minus 2 was not a factor. And my answer would be written as x squared plus 13x plus 57 plus my remainder of 135 over the original thing we were dividing by, x minus 2. Right, 8 and 9 should be similar. So for number 10, if you know something's a factor of a polynomial, or how do you know? You know when the remainder is 0. Right, it is a factor. Number 11, the aquarium has a length of L, a width that is 8 less than the length, and a height that is 3 more than twice the length. So if the length is L, right, length is really L, tells us the width is 8 less than the length. So 8 less than this value would be L minus 8. The height is 3 more than twice the length. So 3 more than twice this would be 2L, and 3 more is plus 3. So those are expressions to represent the width and the height of the aquarium. If I wanted to represent the volume of the aquarium, we know that length times width times height is always equal to volume. So that's L times L minus 8 times 2L plus 3 equals the volume that they told me was 100 cubic units. For 12 through 17, we're determining if a function is even, odd, or neither. So this is based on, if it's an equation, we look at the exponents. If they're even exponents, then it's even function. If they're odd exponents without a constant, it's an odd function. And if it's either mixed or is odd with a constant, it's neither. So looking at 13, I have even, and then nothing. So this is an even function. If I jump ahead to 14, I have odd, even, so this is neither. And looking ahead to 17, I have odd, and this is a 1, so that's odd, so that's an odd function. When you're looking at a graph, if it can be rotated 180 degrees around the origin, then it's odd. If it could be reflected in the y-axis, then it's even. And if it doesn't fit either of those, it's neither. So this one here can be flipped over 180. And I could try to do it now, but it won't work. But this one works the opposite ways, so this one is odd. 15 is a reflection in the y-axis, so this one is even. And 16, since it doesn't go through the origin, if I tried to rotate it 180 degrees, it would not give me the same picture back. Ooh, that's not what I wanted. It is neither. For 18 and 19, we are looking at a graph, and we are describing end behavior, leading coefficient, degree, roots, multiplicities, and increasing and decreasing. So the first thing I'm looking at here is I know that I have the right arrow going up. So based on the right arrow, I can tell you that the leading coefficient is positive. The degree, so I'm going to look at both arrows now. They're going opposite directions. Opposite is odd. If they went the same direction, it would be even. So I know on the right side, it's going up, so that's to positive infinity. And on the left side, it's going down, so that's to negative infinity. For my roots, I cross the x-axis at positive 1. So x equals 1. And because it went through it, I went from one side of the axis to the other. That had a multiplicity of 1. At positive 6, it didn't go through. If it went through, I would have kept going there, or it would have come up from here, but it didn't do either of those things. So this actually bounced at 6, so it has a multiplicity of 2. And when we're talking about intervals of increasing or decreasing, we always start from the leftmost part, and I start drawing my arrow. And when I start drawing my arrow, it's increasing. The arrow's going up, and it stops going up right around here. So let's call that, let's see, 1, 2.5. So from negative infinity to 2.5, it increased. Then it started decreasing at that 2.5, and it kept decreasing until we hit x was 6. So it decreased from 2.5 to 6. And then at 6, we turn around and we start increasing again. So that means from 6 to infinity, it was increasing. All right, you can go ahead and try 19, similar objects. For 20, they're asking us to complete a sign chart. So it's more complicated than this normally, but we're just going to break it down into picking a value that fits this specific domain and plugging it in for all the x's. Whatever sign the answer is, we're going to either write positive or negative. So between negative infinity and negative 9, let's pick negative 10. So that's going to be negative 10 plus 9, negative 10 plus 5, negative 10 minus 3, and negative 10 minus 7. So this is a negative number, right? Negative 1. This is a negative number. It's negative 5. This is a negative number. It's negative 13. And this is a negative number. It's negative 17. So if I were to multiply all four of these numbers, a negative times a negative times a negative times a negative, that comes out to be positive. Now we're going to check something between negative 9 and negative 5. So let's say negative 6. So negative 6 plus 9, negative 6 plus 5, negative 6 minus 3, and negative 6 minus 7. That's going to be a positive 3, a negative 1, a negative 9, and a negative 13. So I have a positive times 3 negatives. So we know 2 negatives cancel out, but I'm still left with a negative. So there it's a negative. Between negative 5 and 3, 0 is the best bet. So if I put in 0, that's 9, 5, negative 3, and negative 7. So that means 2 negatives cancel to become a positive, times a positive, times a positive. Overall, that's positive. Between 3 and 7, we can pick anything. Let's say we pick 4. So we have 4 plus 9, 4 plus 5, 4 minus 3, and 4 minus 7. So that's going to be 13 times 9 times 1 times negative 3. So I have 3 positives times a negative, so that negative makes the whole thing negative. And the last one is 7 to infinity, so let's say we pick 10. So that's 10 plus 9, 10 plus 5, 10 minus 3, and 10 minus 7. So we have 19, 15, 7, and 3. All 4 of these are positive numbers, so when they multiply, they will become a positive number. And that's how we would complete a sign chart. We can now use a sign chart to complete a rough sketch of the graph. So every time a number repeats, that's a 0. So that means at negative 8, I have a 0. At negative 3, I have a 0. At positive 1, I have a 0. At 4, I have a 0. So I plot my 4 zeros. They tell me everything before the negative 8 was negative. Between negative 8 and negative 3 was positive, so it's somewhere up here. Between negative 3 and 1, it was negative, so it's back down here. Between 1 and 4, it's positive. And then after 4, it's positive. So another thing I could have done is I could have looked at my end behavior. I knew all the way to the left was negative and all the way to the right was positive. So I could have started with those two. And that might actually be enough information to get you to your answer if you're choosing a graph that matches your sign chart. All right, but if you can't get it from just the end behavior, look at what happens between your zeros. Number 22, we have 2 different companies that are making profit when selling the products, depending on how many they sell. The profit in dollars based on the number of products sold, X for each company is given below. So they have company A and company B. Which company makes more profit when selling 10 items? So we already know the answer for company B. 10 items is when X is 10. So company B is 72. Now I would actually have to plug 10 into this equation to find my answer for company A. So I could either do it by synthetic, or because I am dealing with some decimals, I might go ahead and just plug it in normally. Okay, so when we plug this in, I'm going to do 10 to the third power, which is 1,000, and that times 0.05 is 50, minus 10 squared is 100, times 0.8 is 80, plus 6.5 times 10 is 65, and then plus 9. So 50 minus 80 plus 65 plus 9 is 44. So which company sold more or makes more profit? Company B. So A is less than B, or you could say B is more than A. All right, for number 23, given that x plus 3 is a factor of the polynomial, find the value of k. So what I can do is I can take x plus 3 and do the synthetic with negative 3, and my coefficients are 1, k, negative 9, and negative 36. So if I bring this down, we have k minus 3. This might not be how I wanted it to go. Negative 3k plus 9. Oh, we're good. So the negative 9 plus 9 really cancels, so we have negative 3k. And then negative 3k times negative 3 is 9k, which means this is 9k minus 36. If I know that this is in fact a factor, this has to be equal to 0. So if 9k minus 36 equals 0, because there has to be a remainder of 0 here, then 9k equals 36, and k equals 4. All right, we're all good there. For 24, identified all common factors between both expressions. So this is already basically factored out. It's 2 times x plus 2 times x plus 2 times x plus 2, right? We could rewrite that cubed to 3 different parts. For this one, though, there's a GCF of negative 2x. And when negative 2x comes out, we're left with x plus 2. So that means in common, let's try to pick a different color. Doesn't want me to pick it. There we go. We have a 2, we have an x, and we have an x plus 2. Right? Those are in common. And the last one, rewrite the function to reveal the vertex. So this is a quadratic in standard form. We know that the vertex is found by doing negative b over 2a. So that's going to be negative 10 over 2 times 1, or negative 5. If I substitute that back in, remember to use parentheses anytime you substitute something in. We have a positive 25 minus 50 plus 11. And if I do 25 minus 50 plus 11, I get negative 14. We know that vertex form the h value is the x value of the vertex. And we already know that the a value was 1 because that's what was in front of x squared. So it's going to be x minus negative 5 or x plus 5 squared. And then the y value is the k value, so minus 11. So this function would reveal the vertex if it had been written in that way. And that is the rest of our study guide for the TCA.